Okay, everyone, would you type into the comments, how do you get this question started? Because we haven't seen this exact question before. And what's the key, whoops, what's the key to getting this question started? And that's right. We're going to need an A, a B, and a C. And when we do that, what you'll see is that if you multiply both sides of the equation by x plus 2, hold on, I know how to see who's, hold on a second. There we go. Okay, so when you multiply both sides by the denominator with all three factors in it, it's not necessary to simplify any further than you have here, where you leave the this stuff unmultiplied, x minus 2, x minus 1. And then when you substitute convenient values of -2, 2, and 1, each one will turn two of the terms into 0. So when I put x equals -2 here, the b and the c are going to get multiplied by 0, and you'd just be left with a, and you can solve for a. Remember, you put the x in place of 1, 2, 3. You put the x into 4 different places. Actually, you put it into 8 different places, but 2 of those places are going to turn the factor or the term into, or that factor into a 0, and 2 of the 3 terms are going to get canceled out. So that's what happens when you have 3 factors. But today's lesson is 2 other types of partial fraction decomposition patterns. And look at this one. 3x plus 17 over x plus 4 squared. Now, you can't do this the exact way we've done before, because you might speculate that you would go like this, x plus 4 . Okay, but what's the problem with starting it that way? You can type it in to the chat. Two zeros, do you mean that if you try to use convenient values method and put in -4, you will get zeros for both things? There's another problem with even the setup, even before you start doing the process, just this setup is problematic. Just right off the bat, looking at this, there's something wrong. And what is that? That's right. DTS says a plus b over x plus 4, because the common denominator is not x plus 4 squared. It's just x plus 4. So it seems problematic here. What you do instead is, the way you can get two things to have a common denominator of x plus 4 squared is if one of them has a denominator of x plus 4 squared. So you see, by doing it this way instead, so we end up with a over x plus 4. Still, we do need this first term, and then b over x plus 4 squared. Those are two things whose will have a common denominator of x plus 4 squared. Now you might say, well, why do I need the first term? Well, if I just have the b over x plus 4 squared, then b would have to be 3x plus 17. It wouldn't be really splitting it up. So this is the way to this is the way to do it. And I mean, it's possible that a or b ends up becoming 0 just by chance, but that's not what's going to happen here. A and b are going to end up being integers. Okay, there's a question. Why are you allowing to square and not just altering the left side? Why are you allowing? Well, The left side of the equation is just the thing that was given to us, the thing that we want to do the partial fraction decomposition for. But I want to split it up into two things somehow, and the only two things, the only two denominators whose least common multiple is x plus 4 squared are x plus 4 and x plus 4 squared. They can't be any other term. Now the first step is still the same as before, or the next step. If you multiply through by x plus 4 squared, we end up with that. And we can do a convenient value with x equals -4. That will get us -12 plus 17 equals 0 plus b, and b is equal to 5. But there's no convenient value to make the b disappear because there's nothing here to plug a number into to make the b. So how are we going to complete this question since we only know what a is? I'm sorry, we only know what b is. So what do you think we should do? That is one way to do it. You can plug any value in for x that you want, and x equals -3 would be a nice one because that would make a times -3 plus 4, and that would make the b is already figured out to be 5, and -3 is -9 plus 17 is 8, so a equals 3. Okay, that's a good idea. What's another way that just to have some options? That's Jonah. That is an excellent idea, and that worked out really nicely. There was another alternative. I just want to have us have all our tools available to us. So what else, if you didn't want to do it that way, by plugging in a different convenient value? Um, there's a mention about multiplying the fractions, but let's assume we're at this point here where there are kind of no fractions left. So what's something else I could do? But plugging in x equals -3 and using the b that you just got is a really good way and probably the easiest way. Yes, you could distribute the a. Basically, imagine you're doing the method number 1. You get ax plus 4a plus b. Let me write that a little bit better. So I have 3x plus 17 equals ax plus 4a plus b. And you see, this is really nice because ax became 3x, so a was 3 that way also. Or if you want, you could take the 4a plus b equals 17, but there really wouldn't be any need to. Okay, so that's how you do it with when there is an exponent here. And if there was a 3 there, you'd have to have a over x plus 4 plus b over x plus 4 squared plus c over x plus 4 cubed. Well, there's only one other question for today. Oh, first I have a practice question for you. So would you take a few minutes to practice the one we just did with this situation? Okay, and if you look up at the screen, you can see that by setting it up properly with the a over x plus 3 and the b over x minus 3, x minus 3 squared, convenient value gets us the value of b, and then I use that shortcut of picking x equals 4, or really any value for x, and the b that I just calculated, and we get the answer, 2 and 5. So that's a real quick question. But the hard part of today's lesson is this kind. So here, and this is why this is the last question after we have this question where I'm going to teach you it, and then I'll have you do a practice one. But this one's kind of lengthy. The issue here is that the denominator has two factors, and one of them is not only not factored, but it's unfactorable. Not the discriminant is negative, so that can't be factored unless you use imaginary numbers. If it was x squared minus 9, you could factor it to x plus 3 minus 3. Even if it was x squared minus 5, you could factor it to x minus radical 5, x plus radical 5. Like you could factor it with into linear factors with a real constant. But this one is what's called irreducible, meaning that its roots are imaginary roots. And here's the way we deal with that. Now, here's the new thing. You might think, well, let's just put a b on top. That's what we've been doing. But it's not a b on top or a c. Anyone have a suspicion? Maybe you've seen this before or have some idea why just putting a b on top would not be sufficient? If it's not just a b on top, what should go in the numerator of the x squared plus 9? B squared is a good idea, but it's actually not going to be a b squared either. And b plus c is also a good idea, like two different things. But there we have from KE, that's what the actual answer is. Bx plus c. See, the numerator was only a constant because the denominator was linear. The numerator has to have a lesser degree than the denominator. And if the denominator is linear, there's only one way to have a smaller degree, which is to have a constant in the numerator. But when I have a quadratic in the denominator, the numerator has to have a smaller degree, which means it could be, there's a chance b ends up becoming 0, and it does end up just having a constant number on top of the other fraction. But it's more likely that there is going to be a b and a c. So that is how you start this question. Now I'm going to give you a quick warning. A lot of people, after they learn this method, they get really, they find this method to be real easy when there's a square here. And then they learn this method. And then when they come back to this one, they are tempted to put a bx plus c here, but it's not. In this case, it's not a bx plus c. This one just gets a b here. And this kind gets a bx plus c there. So I just see often people on like test number 6 accidentally put a bx plus c here because they get confused with this other one. Or they accidentally put a b here. This is the kind with the b. This is the kind with the bx plus c. This is a quadratic that has a repeated factor, repeat of this one. This one's an irreducible quadratic, and the denominator has a negative discriminant. Now, this one is kind of annoying to continue. And let's see why. If you multiply both sides by this denominator, which is the first step, and notice I was pretty careful to put these parentheses around the bx plus c. Because without those parentheses, it might lead to a complication in the next step. Now, the convenient values method, we have an A, a B, and a C. And the convenient values method doesn't work as well as we would hope here. But maybe it will work a little bit. What would be at least a convenient value to get that might work, at least get us, make some progress in this problem? You could type it into the chat. Is there any convenient value that might get us some progress? And that's right. If I plug x equals 2 in, I end up getting the value of a, because this x minus 2 would become 0. So when I plug 2 in, I get 7 times 4, which is 28, minus 18, plus 29, equals a. Oh, was there? Hold on a second. Yes, that's right. Equals a times 2 squared plus 9. It ends up being 39 equals 13a, and a equals 3. So we do manage to get one of the answers. But there's no convenient value. There's nothing that can make the a drop out, because there's nothing that makes x squared plus 9. You can't pick 3i as a convenient value. Even if you did, you still have the b and the c are so intertwined. So now we have to switch over. Oh, and picking another convenient value like was done for the last one as a little shortcut, that won't work for this one either, because of the b and c being so, interconnected like that. So we're going to have to resort to the system of equations. And let's just see. The x squared ends up just being ax, sorry. Let me go this way. It's ax squared plus 9a. And that a we actually know is the number 3. And we will get to replace the a with the 3. Now I have to do FOIL on this one, and I get bx squared minus 2bx plus cx minus 2c. That's why we had to be extra careful with these parentheses, because if you didn't have those parentheses, you might just multiply the c times the x minus 2. So this turns into a plus b x squared plus for the x's, I have a cx and a minus 2a. So I'm going to write plus parentheses c minus 2b x. And then finally, I have minus 2c. Now remember, I know that a is 3 already. I'm just going to erase this little area. So we know that a is 3. So our system of equations is going to be a plus b equals 7. That's the coefficient of the x squared term. C minus 2b is equal to negative 9. And minus, oops, I forgot about the 9a. Thanks, Jonah. This 9a is over here. Minus 2c
No, I didn't.
plus 9a is equal to 29. Now this is three equations with three unknowns, which could be a real annoying thing, but because the A is already known to be 3, this question can be answered in just a few seconds now, because we know A is 3, so with this equation, it becomes 3 plus B equals 7, so B equals 4. And with this bottom equation, we get negative 2C plus 27 equals 29, or negative 2C equals 2, or C equals negative 1. So this A ended up becoming 3. We had that right away. The coefficient of the X, the B, ended up becoming 4. So it's 4X. And the C ended up becoming negative 1. So the partial fraction decomposition is 3 over x minus 2 plus 4x minus 1 over x squared plus 9. And that's how these questions always go. These questions are very easy to make up. All I have to do is just start with the right-hand side and just add the two questions together, add the two fractions together with common denominators, and I can create the question. But do make sure that once you master this one, that when you go back to this type, that you don't accidentally put a bx plus c in this type. The bx plus c is when we have a irreducible quadratic, and the regular b is when I have a repeated factor here. Okay, so we're going to finish up today, and this will be the last question of today. So today's a little bit shorter. Take a few minutes to work on this question. You could chat about it as you work. Okay, I see a question. Yes, there actually are videos. They're just not on the playlist yet, but there's a second playlist. I have to merge the two playlists together. After this lesson, where I have to make a small video for this lesson, there's videos already created on the YouTube channel for the entire rest of the semester. Okay, does someone want to type into the chat what they got for A, B, and C? Okay, Chelsea says A equals 3, B equals 4, C equals -2. And I see a bunch of people have the same thing or close to it. Let's take a look. Present now. Window. Okay, and you can see here that the system of equations is A plus B equals 7, 5B plus C equals 18, and 4A plus 5C equals 2. The convenient value of -5 leads you to A equals 3. Then you could plug that into A plus B equals 7 to get B equals 4. And you could even use the middle equation, the one that has B and C in it, or you could use the A and C equation, which is what I did. Okay, so that is what I wanted to show you today. Let me just stop the video.